think we're on time now to move on to our final short talk. So, William, I'm going to hand the screen over to you. Please go ahead.
Great. Well, thank you for inviting me to talk. My name is William Rees. I'm a PhD researcher at the University of Exeter. I'm also a bat worker in the United Kingdom and an enthusiastic tech user. So I'm going to talk to you today about a project I've been working on called Scaling Bat Roost Surveys, AI-assisted video review. So to begin with, why monitor bats? So globally, bats represent 20% of all described mammal species. Many species are synanthropic in that they live and breed in close proximity to humans, often in man-made structures, so they're at high risk of human-wildlife conflict. They also provide a lot of vital ecosystem services like pest suppression, pollination, and serve as indicators of ecosystem health. So monitoring is extremely important. And video-based monitoring is one of the most effective tools we have available to achieve this. In fact, in the United Kingdom, if you're doing presence-absence surveys that are going to be used for development purposes or conservation purposes, night vision aids such as infrared cameras or thermal cameras are actually mandated. The problem is that this produces a lot of data. So if you're doing a traditional dusk emergence survey, you will record for about 2.5 hours post-dusk. And if you've got multiple cameras, that's a lot of footage to go through, and humans are really bad at reviewing long-form videos. So this project was really about addressing this problem. So exploring specifically, number one, are deep learning image classifiers currently able to distinguish between bats and non-bats in relatively low contrast, low resolution footage, like you can see below? The second was, can we combine motion tracking with an AI-based filter to essentially scrub through long-form videos and highlight events of interest that we can put in front of our practitioners? And the third, and most important tool from my perspective, is to compact all this into an open access tool for conservationists. So to explore this, we worked with a dataset collected by professional ecologists in the United Kingdom, covering 20 sites and 61 independent scenes. We've got a wide range of species in our datasets, small and large, slow and fast-flying species. So there's a list there if you want to review them in more detail. Overall, we had 150 hours of video footage, so quite a lot. And the first thing we did was split it on an 80-20 splits on a location basis. And this basically ensures that everything we're testing on and I'm reporting in terms of performance metrics was not used to train the model. The pipeline involves essentially first detecting motion within videos, tracking motion within videos, and then extracting essentially image sequences from that motion. These tracked objects are presented in essentially a simple web interface grid format, allowing a user or a researcher to essentially go through and very quickly annotate it into different classes. So it's just classifying your motion manually, basically, really efficiently. For our purposes, we chose 4 classes: bat, bird, human, and other. And we converted that 150 hours of video into essentially 85,000 frames of bats, 25,000 frames of birds, 60,000 frames of humans, and a big class of other, which basically represents everything else in our video. We then fed this through a deep learning image classifier. It's a ResNet 18 convolutional neural network. And this basically converts crops from our videos, so 64 by 64 inputs, into basically a vector representation. So it extracts image features and uses that to distinguish the classes. So in our case, bat, bird, human, or other. We then aggregate basically these frame level predictions across an image sequence to get an overall prediction that an object, so the thing you see in the top left-hand corner, is a bat or not. And overall, we were really happy with the performance we're achieving on even a really, really lightweight and small classifier. So this is only looking at 64 by 64 pixels. So it's a really lightweight process. It can run on any basically local hardware. We evaluate performance using first leave one site out cross-validation, so basically training on all our sites apart from one, and then testing on that independent site. So it represents essentially what a practitioner would do, try and deploy it in a new location. And we found it was really effective at distinguishing between our classes, and specifically you can see here 91% of the bat frames were actually returned as bat, which is perfect. But what's also really important is, even though our model is 4 classes, we actually found that the bat head, or the bat class itself, was a really good predictor or detector of bats. So you can see in the top right hand corner, basically all our bat images are in red and they're pushed up to 1, so a confidence of 1, and everything else in blue, all our other objects, are pushed down to near 0. So again, really good, very clear decision threshold. We then basically took this pipeline and ran it on our held out data. So the 41.5 hours of video we initially set aside that we didn't look at all. And what we found was that it was a really effective solution to basically screen and scrub through this data. We found that we returned 97% of all the bat events in the videos, at the same time reducing the amount of motion events we actually needed to review by 86%, and overall achieving a reduction of 98% in the total amount of video footage that a practitioner actually has to look at. So the next and most important step is creating something that people can actually use. And this is currently a work in progress, but we do have a public beta available. The tool is called WingSeat. You can see here basically what we call the review interface, and this presents all motion in the video basically in a very simple and accessible interface. But you can see here, motion is not very informative. That's a lot of information still to go through if you still rely on motion. But when you apply our filter, suddenly the bats appear. So really where we're at the moment is trying to hone the actual usable interface for practitioners. The demo is available by a QR code in the bottom left-hand corner if you want to see a full video of the end-to-end process of analyzing your data. There's a link there to submit clips to our central database, because the more data we have, the better the tool will perform. At the same time, we've got UK species only. It'll be great to see some collaboration on an international scale. My contact details there. I'd love to hear more about what you're doing with bats and whether you'd like to use this tool for any of your research or conservation work. Thank you.
Thank you very much, William. Really appreciate that. It's when you show the image with all the different lines on it, sort of crossing over it, it shows how difficult it is to analyze. But then when you take that off and you see the bats flying around, it suddenly all makes sense. Thank you so much for sharing. Do we have any questions from the chat, from the audience for Will? If not, I do have a question. I was going to ask, because as you said at the end there, the tool is kind of very specific for UK bats at the moment, and we've only got a limited number of bat species. How accessible is the tool going to be for people from other countries or other regions to use? Maybe when they're working with larger bats, diurnal bats like fruit bats, that sort of thing. Is it going to be an accessible tool for them as well?
Yeah, so if we're talking about fruit bats, the visual similarity to some of the large birds we've got in the UK will probably cause a bit of an issue there. But insectivorous bats, generally, it's trained basically on very low resolution image inputs, specifically the silhouettes of bats and their wings. So if you've got the characteristic, Batman silhouette, you'll probably be okay. But ultimately, what we need is data from the international community to really validate this. And part of the platform we're providing is also a showcase on how you can evaluate the tool on your own data as well, which is absolutely critical if you're ever using an AI tool. Figure out if it works on your own data.
Amazing, thank you. We're getting some bat love from Kalindi in the chat, and also David has asked, is there a link to the online platform, or is it still a work in progress?
I'll post the Git repo in the chat. Yeah.
Fantastic. Well, thank you very much.